Now, ladies and gents, we're done with the parabola. Everything you need to know for the parabola is there. If you haven't watched them yet, please make sure that you start from the beginning of this playlist. Now we're going to introduce the second type of a function, which is the hyperbola. Hyperbola, I need you to know how to find 6 things: the asymptotes, domain and range, axis of symmetry, x-intercept, and y-intercept. We're going to discuss how to find each from just the equation that is given. You don't need a sketch to find any of those 6 things. Ne? Perfect. If you don't know how a hyperbola looks like, don't worry. Just follow through with the lessons. You'll see how we sketch it. But for you to be able to sketch it, you need these 6 things first. Ne? After we discuss these 6 things, the next video, we're going to sketch it. Okay, perfect. So the first thing that we're going to do is the asymptotes. Ladies and gents, asymptotes are those lines that the graph is not going to touch. It's those lines that the graph is never ever going to touch. Those are the asymptotes. Ne? And this graph has 2 asymptotes, ne? Which is the x-asymptote and the y-asymptote. Ne? So hyperbola has 2 asymptotes, the y-asymptote and the x-asymptote, right? The x-asymptote is easy to find. It's always the x value that when you put here, you're going to get 0, right? So obviously, if I have positive 1 here, I must put negative 1 so that the whole thing will be 0. Does it make sense? So I'm going to put negative 1 as my asymptote. Ne? Perfect. Before I move on, I just want to discuss something. Let's say here we had a negative like this. Ne? So do you agree that our asymptote was going to be positive 1 then? So that I'm going to have negative 1 plus 1. So it's always the x value that when you put at the bottom, you have what? You're going to have your final answer as 0. Don't forget that, ladies and gents, okay? Perfect. Sharp, that is your x-asymptote. Now let's go to our y-asymptote. I need us to agree on something before we get our y-asymptote. Remember, this part here, right? This part here will never be 0. No matter what the x value we put here, we'll always get an answer for the fraction, right? Otherwise, if we put negative 1, the fraction is undefined, which is the asymptote. So I'm sure we all agree that this will never be 0. It can be any other thing, but not 0, right? So which means if this is not 0, it means whatever is here, when we add to 2, ne? It means we will never basically have the final answer. Okay, let me do this. Because remember, we add in the 2, ne? So we will never have the final answer being exactly 2, because this will never be 0. So we'll never have 0 plus 2. Ne? So basically, this will be your y-asymptote, always. Ne? That is your y-asymptote. 2 is your y-asymptote. The basic form of a hyperbola is this: f of x equals to a over x plus p plus q. Ne? Q, the number that is on the side here, will always be your y-asymptote. Don't forget that. Here I was just making it complex by explaining it. If you don't really get what I was saying, just know that Q is your y-asymptote. And ladies and gents, asymptotes are our restrictions. Why? Because we're never going to touch them, remember. So domain will be x elements of real numbers, but x cannot be what? Cannot be negative 1. We'll never touch negative 1. Ne? And then same as range, y elements of real numbers, but we will never touch. We have a restriction at y equals to 2. That's how you do the domain and the range for the hyperbola. You need to firstly have your asymptotes, and then you can easily do your domain and range. I'm sure that it's pretty simple. Now let's check the axis of symmetry lines. The axis of symmetry lines, ladies and gents, are basically the mirror images of a hyperbola. Ne? They are the mirrors. They are the mirrors, mirror lines. Ne? That's why we say symmetry. They are the mirrors, mirror lines of the functions. Ne? Sharp. So if you don't really have a picture of it, don't worry, you'll see them when we sketch the graphs. Now I need you to know how to get them. Ne? There are two of them as well. Okay, let's start with the first one. The first one is this. Listen carefully. You take the bottom the exact same way it is, you add to the Q. So you take the bottom, you add to the Q. So which is x plus 1 plus 2, which is x plus 3. That is your first axis of symmetry line. So, and we can see that the gradient is 1, right? So this one, the question here, they usually say axis of symmetry line that is increasing because the gradient it's positive 1, or they'll say find the axis of symmetry with a positive gradient. Ne? Positive gradient. So this axis of symmetry line is increasing. Ne? Sharp. The second one is this. Listen carefully again. You still follow the same procedure, but now the bottom part must switch. Ne? This is the bottom, remember, it's x plus 1. You switch all the signs there. So this is positive x, it now becomes negative x, and then that becomes negative 1. The Q does not switch. That's how you find the second axis of symmetry line, which is negative x plus 1, right? So you can see that your gradient here is negative 1. So it's going to be decreasing because the gradient is negative. Decreasing axis of symmetry line, or the question will say, find the axis of symmetry line with a negative gradient. Right. Perfect. Now we're going to do the x and the y-intercept of this function. The x and the y-intercept of this function. Okay. Perfect. The easiest one to start with, it's always the y-intercept. Remember, the y-intercept is when x is 0, right? We make x 0. So which means our input is 0. So which means we're going to input 0 there. So we have f at 0 equals to 2 over 0 plus 1. Then we have plus 2 there. Then f at 0 equals to, this is 2 plus 2, which is 4. So when x is 0, y is 4. Do you see it? So your intercept is going to be 0, coordinate 4. That is your y-intercept, right? X-intercept, remember, we make y 0, and f of x is just y, right? So which means this whole thing here becomes 0. This part here becomes 0, right, for the x-intercept, right? Perfect. So you're going to have 0 equals to 2 over x plus 1, and then plus 2, right? And then you take this plus 2 that side, which becomes negative 2 equals to 2 over x plus 1, right? And then you're going to cross multiply. Now remember, this is 2 over 1. So this will multiply with that. We do the cross multiplication. So you have negative 2x plus 1 equals to 2 times 1, which is negative 2x minus 2 equals to 2. And then you take this, that side, which is negative 2x equals to 2 plus 2. Then you have negative 2x, this goes there, negative 2x equals to 4. Then you want to isolate the x, you divide by negative 2 both sides. So x equals to, this will give you negative 2. Therefore, the x-intercept will be negative 2, coordinate 0. Right. And that's it with the first one, ladies and gents. We found all the 6 things, which are easy, right? Now let's do the second one. I'm going to write them in different forms to try to show you how they can trick you. But they don't usually try to trick you in hyperbola. They write it in this way. But I just want to show you for the fun of it, right? Okay, so number 2. But I'm not going to do x and y intercepts for this one because the procedure is the same as the previous one. So here, ladies and gents, you have x, but you need to have y there. So the first thing that we're going to do is to write y as the subject of the formula. I'm going to try to write y as the subject of the formula. Okay, let's do it here. The space here. Right. Okay. So basically I have x over 1. I have 5 over 1, right? Sharp. So what I can do here is this. Let's see. I'm going to firstly remove, let's do this. I'm firstly going to do this LCD, which is this part, right? So I'm going to multiply this there and also multiply it there, right? So we're going to have x, right? Okay, actually, let's just take this part to that side first. So we're going to have x minus 5, right? And then we're going to have 3 minus y equals to 2. Let me explain what I did here. I firstly moved the 5 that side, so I'm going to have x minus 5 equals to 2 over 3 minus y, right? But this is over 1, and then we do cross multiplication here. So this will multiply with that, and then 2 times 1 is still 2. Then we have this. Do you see? Sharp. But we know that this part is the bottom part of the hyperbola. I'm not gonna foil here. If you foil, it's gonna get more complex. So you have 3 minus y equals to 2 over x minus 5. So you divide it by x minus 5 both sides. Right. And then you now have negative y is equals to 2 over x minus 5 minus 3. You move the 3 to the other side, right? And then you're gonna switch all the signs because you need your y to be positive. So positive y equals to, here if you have a fraction, guys, the negative just affects the top part. So you're gonna have negative 2 over x minus 5. Then it will also affect that one, plus 3. And then now you have your hyperbola in the standard form, right? Then when you have it in the standard form, it's now nice to work with. You can easily get your asymptotes. So asymptotes are going to be x equals to 5, because when I put 5 here, I'm going to have 5 minus 5, which is 0. Do you see it? Perfect. And then remember we said y is always q, so y is 3. Then domain x e r x is not equals to 5. Range y is not equals to 3. Done. Axis of symmetry. Remember the axis of symmetry, you take this, you're interested in that part and that part, right? So the first one, you take them the exact way it is, x minus 5 plus 3, which becomes x minus 2. That is your first axis of symmetry line. Or y, remember you only switch the bottom. So you're going to have negative x, this becomes plus 5. The q always remains the same, which is negative x plus 8. And you are done with number 2, ladies and gents. I love this curve. The hyperbola is one of the easiest. Actually, maths in general is an easy subject. You just need to know the rules, right? Perfect. Okay, let's go to number 3 now. So on 3, as well, we need to make y the subject of the formula. So I have to divide by x plus 2 both sides, right? x plus 2. This will cancel that. So I have y minus 2 equals to 3 over x plus 2. Therefore, I'm going to have y equals to 3 over x plus 2 plus 2. This part will go the other side to be plus 2. And then we can see that your q is 2, which is your y asymptote. And then the opposite of plus 2 is minus 2. Because if I put minus 2 here, I'm going to have minus 2 plus 2, which is 0. Domain XER, the restriction is x cannot be the asymptote. And then YER, the restriction is y cannot be the asymptote. Then axis of symmetry lines. Remember the first one, you take the bottom, you add to the q. So x plus 2 plus 2, which is x plus 4. And then the second one, you switch the bottom. So you only switch this part, which is on the bottom. So it's negative x minus 2 plus 2, which is just negative x. That's interesting, because this part will be 0. Do you see? And that's finito with this video, ladies and gents. Please leave the comments. If it's helpful, say if it's helpful. If you saw a mistake somewhere, please let me know. If you feel like I'm moving too fast, let me know. If you feel like I'm moving too slow, let me know. And if overall it's perfect, please don't forget to hit the subscription button and to share with family and friends. You know, sharing is caring. Plug your friends with Maths Fanatics 24/7. Aluta continua. Tango.